So the first problem on the Tylenol worksheet says acetaminophen is available in 325 milligram tablets. 650 milligrams has been prescribed PO. How many tablets will you administer? So this is a very easy problem that they can actually visually see the answer to. But the way we explain it is that's not the point. This is deliberately made easy so that you can learn how to set up your calculation so that you will understand the method later on when things get more complex. So in this method, and we'll call it method one, and they set up with what are they looking for first. And the reason that I like this method is it helps the students to see what comes next. What piece of information do they need to place into the equation next? So the first thing it's asking is how many tablets? So the student knows they are looking for tablets. So they place that first in their problem. Okay. Then goes an equal symbol and a fraction bar. And for the first problem, the way I explain it is you're going to go horizontally for the very first section. That's the only time. So if it's tablets here, then you need tablets on top here. And that's the most important key factor to setting it up so that the problem tells you what comes next. After that, I tell them then you're going to begin doing what we call cross matching. And that's really what it is. It's a game of matching. So if you have tablets on top, you go back to your problem to figure out, well, where does it talk about tablets in my problem? So it starts at the top and it says you have 325 milligram tablets. So every one tablet has 325 milligrams, and that these are connected and they cannot be separated. So if one tablet has 325 milligrams, they've begun to set up their problem. So then the next part is to use a symbol that means multiplication. So that could be a dot, it can be a bar, it can be the X, whatever the student prefers, and the fraction bar. If milligrams is on the bottom in the first fraction, it must be on the top in the second fraction. So that helps them to see what comes next. So then they go back to their problem. They've already used that part. So the only thing left is the order, which is 650 milligrams has been prescribed. So 650 goes there. And then I just tell them there's an invisible 1 here. Now the question that the student needs to ask themselves is, am I finished setting up my problem? And the way to check is to cross match the units of measure. So this is dimensional analysis is all based on units of measure. So if you have 300, if you have milligrams on the bottom here, you can cross out milligrams on the top here. And what remains? Tablets. And tablets is what you're seeking. So now you know you have set up your problem correctly and you don't need any further conversion factors. And then the next step is to multiply all the numerators together. And in this case, it's 1 times 650, which equals 650. And then the next stylistic thing is they can divide one at a time each denominator into that 650 by 325 by 1, or they can again multiply all their denominators together. It's really a stylistic preference. 325 times 1 is 325, and then you divide your denominator into your numerator, which equals 2. And then I ask the students to what? They go back to their problem. It's 2 tablets. And that's the initial lesson in how to set up dimensional analysis using what we'll call method one. Problem number two on the Tylenol worksheet states 500 milligrams scored caplets of acetaminophen are available. The bottle contains 200 caplets. How many caplets should be administered if 1 gram of acetaminophen is prescribed? So the way I break this down for the students is I let them see visually 1 caplet scored is equal to 500 milligrams. And then I show them the bottle has 200 caplets in it. And I ask them, does that matter? Is that an important number in this calculation? No, that's of really no value unless you're counting NARCs. And the order is for 1 gram to be given of acetaminophen. So they know that they have to give. So then the question is, what do I have to give? You're going to give a caplet. And so that's how you begin. And then the equal sign, fraction bar. The first one goes across, so it's cap here. So then they go back to their problem, which is 1 tablet has 500 milligrams. So one caplet, sorry, 1 cap, 500 milligrams. So now they've set up their problem. Okay, we'll use the bar for this one. Milligrams is on the bottom, so they know milligrams must go on the top. They're going to go back to their problem. They've already used this one. So the remaining one is 1 gram. So this is where they start going, oh, wait a minute, 1 gram. But you see, it's telling you now, where does my conversion factor go? So they can recognize this is a conversion factor. So the conversion factor for this one is 1,000 milligrams is in 1 gram. Multiplication, put your next fraction bar in. Okay. And then they go back to their problem, which is their order. The ordered dose is 1 gram. So now they've got 1 gram on top, and the invisible 1 goes there. Now I ask the students, ask yourself, have I completed my problem? Do I have all the conversion factors I need? Is everything set up? And the way you know that is by cross-matching all of your units of measure. So the grams matches, so you can cross them out. Milligrams matches, so you can cross that out. The only thing remaining is caps, and caps is what we're seeking. So then they multiply all their numerators together, which equals 1,000. And then either 1 by 1 with the denominators or all together, 500 times 1 is 500. Divide the denominator into the numerator, and you get 2. And I ask the students, 2 what? 2 caps. And that's how you calculate for capsules. Problem number 4 on the Tylenol worksheet brings in more of the conversion factors, which is an area where the students struggle. They really struggle with problem number 4 because it has a lot of content to it. And so I help them to begin by breaking it down. A child weighing 66 pounds comes to the clinic with a fever of 39.2. He needs acetaminophen given at a dose of 15 milligrams per kilogram. Acetaminophen suspension of 160 milligrams per 5 ml is available. How many teaspoons will you administer? So the way I help the students to break this down is I use some imagery here, very rudimentary imagery, and the order is for 15 milligrams per 1 kilogram. And the bottle that you have is a suspension of acetaminophen, which has 160 milligrams for every 5 ml. And you have a child that weighs 66 pounds. So that helps to break down the information in the question. And then they're going to begin to set up their problem, which already told them how to begin. It asks for how many teaspoons. So they put teaspoons there, equal sign, fraction bar, teaspoons, because it always goes horizontally for the first one. So they know teaspoon is on the top. And so I say to them, go back to your problem, and where does it say teaspoons? Ah, they hit a roadblock immediately. And this is where I say to them, look at your conversion factors, and I give them cards that have the conversion factors on that they need to memorize. They go to their card, and it's 1 teaspoon is equal to 5 mLs. So that begins to set up their problem. Next comes the multiplication symbol and another fraction bar. Now, because they have mLs on the bottom, there must be mLs on the top. So now they know what they're looking for their next part of the problem. So they're going to go over to their suspension, which has 160 milligrams per 5 mLs, because that's where the ml is. So it's 5 mLs in 160 milligrams. Okay, now they have the next setup of their problem. Multiplication, fraction bar, milligrams is on the bottom, so milligrams must go on the top of the next one. So they've already used this one, so cross that out. So milligrams comes into play here with the order. It's 15 milligrams per 1 kilogram. So 15 milligrams, 1 kilogram. Again, multiplication, fraction bar. Kilograms is on the bottom, so kilograms must go on the top. Now they go back to their problem and they're saying, okay, where's the next kilogram? Well, there isn't any. They used this one. They've used that one. What we have left is pounds. Okay, I see a conversion factor coming, and this is where I tell them that if you don't know and you don't see it in the problem, most likely that's a conversion factor. So look at your conversion factor chart and or memorize them. It's 1 kilogram is equal to 2.2 pounds. Okay. Multiplication, fraction bar. Pounds is on the bottom, so pounds must go on the top. What do we have in our problem? Is there pounds anywhere in our problem? And I take them back to their child. How much does your child weigh? Your child weighs 66 pounds, invisible 1 on the bottom. So now the next question that I ask them is your problem complete? Do you have all of the conversion factors that you need for this? And the only way is to go back and cross out all of your units of measure so that the only thing that remains is what you're seeking. So if we started at the beginning, we have milliliters on the bottom and milliliters on the top, so that one works. Milligrams on the bottom, milligrams on the top, so that one works. Kilograms on the bottom, kilograms on the top, that one works. Pounds on the bottom, pounds on the top. So we've crossed out all units of measure except for teaspoons, and teaspoons is what we're seeking. So now we know we've set up our problem correctly. 1 times 5 times 15 times 1 times 66 is equal to, I'm going to put it down at the bottom here, 4,950. That's our numerators all multiplied together. And then if we multiply all the denominators together, 5 times 160 times 1 times 2.2 times 1 is 1,760. Divide the numerator by the denominator, and you're going to get 2.8125. And this is where I say to the students, what? Teaspoons. Okay, and this is where I begin to instruct them on rounding. And I do have a really nice rounding sheet that explains the principles of rounding for med calculations. And so the 2.8, the 8 is going to raise the 2 to a 3, and their correct answer is going to be 3 teaspoons. And that is method 1, I'm so sorry. And that is method 1 of dimensional analysis.